everyone. We will be solving question 16 of GATE Chemical Engineering 2019 paper from the subject of heat transfer. So the question is, consider the two countercurrent heat exchanger designs for heating a cold stream from T in to T out as shown in figure. The hot process stream is available at capital T in. The inlet stream conditions and overall heat transfer coefficients are identical in both the designs. The heat transfer area in design 1 and design 2 are respectively A1HH and A2HH. We have been given the general schematic. If the heat losses are neglected and if both the heat designs are feasible, which of the following statements holds true? Okay, so we have been given this heat exchange design parameters and the general schematic of the countercurrent heat exchanger, and we have to find which of the following options is correct amongst the given one. So let's solve it. So for design 1, let's just write the energy balance. So let's see. For first design, we can write the energy balance as mCp delta T, and here we have been given M as the mass flow rate as F in. So let's just write F dot in. Let's just write the heat capacity as Cp. So let us consider this as tube side and this one as shell side. So corresponding to that, we can write this for tube side fluid as Cpt, and the temperature difference is T out minus T in. Similarly, for the shell side fluid, I can write it as T out given as 1. Similarly, I will write this for now secondary design. Here the flow rate and the other parameters for both this heat exchanger design were given as constants. I will just replace them as the same. The inlet and outlet temperature T in and T out same as the previous one. But in this case, the T out we have been given as T out 2, and in the earlier case it was T out 1. So we have been given that all of these parameters are same. All of these parameters are same. So from this, okay, so over here this T out, yes, so all of these parameters in first design and second design are same. So I think all of this can be cancelled out, and we can see that this term are the only different ones, so they must be same. So that is, we can write so we can write T1 out is equal to T2 out. Now from the given options, we have this option B and option C, in which the given options are, that is T1 out is equal to T2 out. Now we need to compare the area of heat exchanger for both of these cases. Okay, now in this is first design, this is second design, and in the second design you can see that this cold fluid T in is getting mixed directly to the outlet, whereas in the first design no such case is happening. So from this diagram that you can see that since the cold fluid is getting mixed directly to the outlet, in the second case this T out will decrease. Okay, so from that we can write it as T1 out is equal T1 out will be greater than this T2 out. So ideally this should have been the case, that is T1 out should have been greater than T2 out, but from the diagram we can see that both the temperatures are same. Okay, so from that we can see that ideally this T2 out should have been lesser, that is T2 out should have been greater, but since we are what mixing this cold fluid, the temperature is less. So ideal T should have been higher. T out T2 out should have been higher than T out. So for 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 design 2, we need to produce this higher T out. So for design 2 to produce higher T out, we need to increase the area of heat exchange. So if the area of heat exchange is higher, then this T output will be higher. That will be ultimately compensated by mixing it with this inlet stream. So yes, since we want to produce this higher T out, we need to increase the area of second heat exchanger. That is, area of second heat exchanger will be greater than area of first heat exchanger. Okay, so from this we are getting the area of second exchanger heat exchanger should be higher, and from the first energy balance we got that T out should be equal to T2 out. So yes, from here we can see that in the option D we are having the area of second heat exchanger is higher, whereas the outlet temperature of both the shell side fluid are same in option D. So yes, the correct option is option D.